Well, welcome everybody to the September Chicago Data Professional User Group meeting. Tonight we've got Alexander Mueller with us, and he's going to be talking to us about less rules, more engineering with encrypted data in use. So Alexander's a mathematician and a data scientist and entrepreneur. And so welcome, Alexander.
Yeah, thanks. Quick question. Will people on YouTube have access? I guess we could put the links I'm sharing in the comments probably or something like that when the time comes.
Yes, we can. Yeah, we'll get those out there.
Okay, good. Because I'm going to refer to them and I don't want to leave the YouTube audience hanging. Okay, probably trivial to just put them in the comments. Okay, thanks a lot. What I would like to talk about today, kind of two threads that I'm going to try to bring them together. One is a not very well known but pretty important ongoing data privacy regulation, kind of, you could almost say, train wreck. And the real short story is that it's been kind of true for a long time that maybe a lot of what Facebook does operating in Europe is illegal. And it's been kind of a lingering issue. What I do, my company works with the encryption-oriented corner of what are increasingly called privacy-enhancing technologies. So particular things like homomorphic encryption and zero-knowledge proof. And you could call these all encrypted data in use. So I'm going to talk a little bit about like what are these new technologies and who cares. But then I'd also like to, just give us an example. This kind of technology solves this data privacy conundrum that the world has been kind of drifting into. So two threads. I'm going to talk about the data privacy stuff first. Kind of a not very well known story, but an interesting one. Anyway, so the links I put in that hopefully are available in some form. My company has a software development kit for doing these kinds of techniques. We like to think it's pretty easy to use, and it's something you can do in a Jupyter notebook in Python. So we have a binder server set up, and you can just play hooky on the whole talk if you're reasonably comfortable with Python and Jupyter notebooks, and just kind of see, what I'm talking about if you're that sort of learner. Second, I have a link to an article about. It sounds nuts, and this one is not that old. This particular article about the Irish data regulator, which usually sets the tone for all of Europe for legal reasons over there, is kind of talking in this weird coy way about like conceivably shutting all Facebook data flows down. Which, if that sounds really heavy duty to you, it probably is. And I include this particular link because this sort of like background threat story has been going on forever. I have a different article linked slightly older in the deck. So it just all goes by saying this has kind of been dragging on. It doesn't have a clear resolution. It's just a generally strange situation. I'll say more in a second. Okay, I also give a link to the slides. So you can always go look at the slides. If something I said was unclear or you want to get in touch with me, hopefully you have good access to that information. So I'm going to try to share my screen now. Please shout at me if it doesn't seem like it's working how it should be working. Everybody see okay?
Yeah, it looks good.
Okay, so what's on the agenda? I'd just like to argue that this particular kind of technology, I'd like to make you aware of what it is, and that it's something that exists now. And then just this data privacy story, I think, is A, just really interesting and not well known. And then B, does a good job telling you the story of why you might uniquely need something called encrypted data in use. So if you just encrypt something and you leave it somewhere until you need to use it, and then you decrypt it, that's encrypted data at rest. The idea of encrypted data in use is you can keep stuff encrypted all the time. We'll talk a lot more about that. Okay, super briefly about me. A lot of people come to data science from other places, and I sort of came from a number theory background that overlapped with the cryptography world a lot. I used to work in healthcare, and I just got really frustrated. Honestly, I'm guessing other people have had similar experiences. Got frustrated about you need all this data, and it seems like you kind of have too much data on people, but then there's all this headache. So I learned about all the amazing research people were doing, ways to give people more privacy. And I thought that was really the ticket for a lot of headache I saw. So I've been down that rabbit hole a long time. And that's the sort of thing my company works on. So on this slide, if you want to get in touch with me, email works. We have GitHub with some of the stuff you might see on that binder page. And then I'm on LinkedIn a lot. And I post video there. So if you like this video, there's more available. Okay, so this was the article I linked. This has just been going on a long time. So there's always a recent article about something happening where there's a problem with what Facebook is doing with their data. But really, it's been going kind of unresolved for years and years and years. Before I go further, has anybody heard of this kind of saga before? Is this totally new or vaguely familiar?
Totally new to me.
Okay, cool. So yeah, this has been mostly the preserve of like data privacy officer sort of crowd. And you could say in a way it's like threatening apocalypse all the time, but has yet to tangibly matter at all. So anyway, I'll keep going. So there have been historically these two phases of the United States and the European Union get together and have some kind of powwow about, well, what are our different privacy law situations with data, and what do you have to do if you want to move data to the European Union from the United States? And the story has been, and it's got this very like the world must repeat itself forever quality now. They've twice had these kind of diplomatic agreements, and then European courts have decided that they are illegal. So what's the problem? If you know the whole Edward Snowden story, he blew the whistle on that the NSA can do digital surveillance on a whole lot of pretty much all digital communications in the United States. And from the eyes of a European Union court, if there's no kind of guarantee that European Union citizens will get caught up in that dragnet, which there seems not to be, then it's illegal for data to go to the United States from Europe without some kind of additional protection. And the public enemy number one for a lot of these issues, in the form of a really famous company that really pushes the issue really far, is Facebook's a really good prototype. And so real quick, this is like going on all the time. And it's mixed in with all the other complicated issues that we're, talking with them at any given moment. So even just in the past few months, they've been talking about getting a new one. How is it going to work out? Nobody knows. So just to summarize, all told, there's this weird situation where, what is the legal rationale for what Facebook does in Europe? It's actually like in really bad shape, and just a kind of endless weird situation is the story. So is everybody tracking so far?
So far, so good.
Yeah, same here.
Yeah, okay. So a name that's attached to this, a famous name worth knowing about this topic, is Maximilian Schrems. And he's an activist. And so he basically sues, I think usually Facebook actually, whenever they make one of these new arrangements, and he's been winning. So there's this kind of weird sense now that, how they're doing things now, even if they come up with the new agreement, will it withstand the inevitable legal challenge? And it feels like the answer is probably not. And then you could also be kind of despairing on the other side, like, I mean, it doesn't seem to matter, and that they kind of always threaten to shut Facebook down, as wild as that sounds, but it hasn't happened yet, and people kind of don't know how to price that risk. Okay, so if you work with a company that does data mostly in the US, you'll probably not have to worry about this anytime soon. If you're working for a bigger company that takes data internationally, it might just be dictated to you by a compliance person. But I'm going to go through, it's actually quite expansive, the kinds of data that will get you in trouble if you're a US company trying to take data out of the EU. In particular, like any kind of information about people will get you in trouble. And then just having data go to, if you had an Amazon server you stood up in Iowa, well, if the data from the EU national is passing through that server, that's actually a problem. There's a lot of story now about like what do companies actually do, I think is worth talking about. And I want to put forward the kind of high-tech stuff I'm going to talk about in the second half of the presentation as a nice way to solve this problem that is sort of future-proof and isn't going to evolve under you every time there's a funny round of the government making a new agreement, etc. So in particular, like what people have been doing now with these problems are, if you just don't really need to use the data, you can just keep it encrypted. You're just storing it in the United States, for example. You're fine. I'll talk more about that and where this kind of other technology I'm talking about is different. Has anybody heard of a standard contractual clause? Probably not.
I have not.
So a standard contractual clause is there's a sort of short list of good reasons you can move data. And basically, for every time you move data, you can essentially, you might have a lawyer involved in this at a bigger company. Okay, so this is the rationale of why we can move it relative to something in the guidance from the European Union, so it's okay. And so this is kind of obvious. Well, this is a great solution if you really are doing some really small circumscribed thing with the data you can describe in detail at the beginning and which is kosher. But then a bigger company that views, they might have a whole lot of data and they might view that generally as a data asset. And that's the sort of Facebook, Google end of the spectrum. You could call that a data fire hose, and there's probably no good way you're ever going to write down a bunch of standard contractual clauses to make it okay. And so these last 4 bullets, they sound kind of cheeky, and I almost don't know if I really feel that way about them or not. And that the situation with Facebook, which is ongoing, and you can, and I think maybe should, if you're interested, follow. It's like Facebook's always kind of illegal, but then it seems like they do a good job of kind of scaring the Irish government into not pulling the trigger on them. And it's just like a real weird limbo. And it's not clear what's going to happen. Okay, so where does this new technology enter as something useful? The recent guidance from the European Union basically says, if you can keep data obscured somehow, it's okay. And so sort of backward looking, the way you would probably be doing this is, if you're just storing it, or you don't have to compute anything on it, or if you had maybe really good tokenization or something, you'd be okay. But the point of what I'm going to talk about in the second half is, what if you wanted to actually serve an application and you really needed the data, so you couldn't keep it encrypted in the sense of some of the older tech. And the idea here is exactly that in this new tech, you can do all the computations that you need to serve the app in this sort of parallel world where everything stays encrypted. So in a lot of ways, from the perspective of the end user or from the perspective of the people hosting the app, you kind of get both ways. You can serve this application in Europe, but then you don't have to get caught up in these regulations. You don't have to do standard contractual clauses because you're not actually decrypting the data ever. I'll talk a little bit more about that in a second. Okay, did you guys happen to look at the binder server?
I haven't, no.
Okay, that's totally cool. Nobody ever does. It's pretty easy to use. You just got to click on that and it'll open this stuff up. But that is just example notebooks of some of the kind of computations I'm going to talk about. Okay, so just to provide some contrast, there's some stock terminology about when you encrypt data in the cybersecurity world, data risk world. There's this idea of data at rest. That's where you just encrypt something and leave it on your computer. There's data in motion, which is like TLS, like everything we're doing right now is going through the web. Actually, I don't know, but whenever you go to an HTTPS website anyway, everything's encrypted a particular way. And the idea of this new tech, and it's kind of counterintuitive, so I'll try to spell it out, is encrypted data in use. So the data stays encrypted, but you can get some particular type of use out of it. And I'll talk quite a bit more about what this is because it's a little confusing. Does this make sense so far? So the idea is like you can have a data pipeline. Maybe everything you were doing on that data pipeline you can actually do while data stays encrypted.
Yeah, I'm having a little trouble wrapping my mind around this.
Yeah, okay. So thank you for your candor. It's not easy to understand, I don't think. Or specifically, it seems kind of too good to be true, and people kind of don't trust it for a while. So I'm going to explain more. So once again, this binder is available now or in the future if you're a YouTube viewer or if you just decide you want to look at it later. You can tinker with this stuff directly, which is helpful. Okay. So I wanted a pretty simple example that is pretty useful if you're somebody who works with databases a lot. Is a lot of the work you might do working with databases is joining tables and stuff like this, right? And then maybe filtering on, we want this or that kind of value. And what I want to point out about this task is a lot of it you can do not really caring about what's in the data. It all just depends on where something in a joined column overlaps with something else from another table. So you might be joining on name, for example. And a really simple idea of a computation you could do with these kind of techniques I'm talking about is, what if I gave you two strings of encrypted data and I just wanted to know, if I could decrypt them, I just want to know, true or false, yes or no, would they be the same name? And so this is exactly the kind of magic trick I'm talking about here. You can do some really special mathematics and say, well, if you were to decrypt this, would these two, names I want to join on, would they be the same, yes or no? But I didn't actually have to learn the name for that. That's the kind of cool magic trick. So to the extent I had a job that was orbiting around things like, well, I need to join these tables and I need to filter these codes that mean that, I don't know, like somebody didn't pay their bill. That's what we're working on for this. Imagine it's a dashboard, I guess. We're making a dashboard about who didn't pay their bills. And we need to join some tables. That task, you don't actually need the data of seeing people's names. You can just figure out this encrypted name is the same as that encrypted name. And that's really what you need to do your job for a lot of people in the more engineering layer. Okay, so this is like a very specific example I've belabored a lot. Does it make sense to everybody? So asking, would this be the same if I could decrypt, yes or no? That's not quite exactly the same question as, hey, could you decrypt for me so I can compare the actual names and therefore learn them?
Well, I would think though that I guess the problem I'm having with this is that sooner or later you have a name that's a Gnip there. Sooner or later, when you're gonna display that name on a screen, Gnip has to turn into Ross Reed.
Yeah, and so the idea is that our particular widget has a permission system, and the idea is that that permission conceivably could be only for the person viewing the dashboard. So in my example, this would be somebody in Europe. But maybe you in the United States, you're joining up all the tables and validating the data size and things like this. You would be working with the encrypted data, and you would only need to see, yeah, it displays the expected 5 to 10 people. And it would be only in Europe that they got the key to actually decrypt, is the idea. That's a great observation, though. This is really a sort of technology about you want to encrypt the whole pipeline. It's kind of a tough, like you can't really escape from, if people see data in plain text for their job, then they see data in plain text for their job.
Yeah, so as a DBA, I might I wouldn't necessarily have to see the decrypted data.
Yeah, and so this is a very specific example, but I've never been a DBA, but I've made DBAs mad at me, so I can maybe guess at what kind of stuff DBAs think about. So, like people are submitting queries. You could look at things like, well, how many queries are there, and you could analyze the queries, and you could even see, aspects of the results of the queries, and then you could maybe filter them further, right? Like, is this field a null or whatever? That's once again not the same as just seeing the data wholesale. But depending on what you were doing might answer your questions. You could look at what sort of data is is this occurring? Like how many values does this column take, etc. It's also worth noting that we talk to companies about, when you actually want to use something like this in practice, it's pretty common that there's use cases where there's a couple different roles at the company that maybe need to do different things. So a kind of stylized dichotomy is that somebody more on the engineering side might care less about seeing individual rows of data. They live in a much more aggregate world. Often, for whatever reason, nearby there's some kind of subject matter expert who maybe really does want to look at, oh, hey, these are the 5 or 10 rows that we think are important or representative somehow. And you would, of course, still let that person that had a real need see that data. It just maybe not everybody needs to see that data. Okay, here's a facetious example. I have a couple standard shticks just explaining how does this tech work. So, like what if I wanted you to sort of audit my books, but my books are really secret, right? This is presented here kind of facetiously, and I won't take a volunteer since I think it's a light room, but if somebody gave you this assignment, of course, you couldn't do it. You couldn't do it. And it's worth noting that if the ask was just to verify the end number, that's really a statement about just the internal relationships. And I shouldn't, and someone would like, do I need to know what the numbers were? And the punchline is that you can exactly do this with the kind of tools we're talking about. And that's really the point. But I'm going to name two tools in particular. Okay, so the first one, I already talked about this. And this is the defining awful mouthful of marbles technical terms part of the talk. So, it's worth knowing, but don't be too, if you felt like you got the gist of the other sides, and this was kind of great to you, don't be too intimidated by it. But anyway, so homomorphic encryption. This is one of the more kind of discussed jargon words in this space. The idea is that if I was going to add 5 and 7 as part of serving some application, adding up rows in a spreadsheet or whatever, respond to a query, but 5 and 7 are secret. Homomorphic encryption is the idea that you can encrypt in a special way. So I encrypt 5, I get some kind of ciphertext. I encrypt 7, I get some kind of ciphertext. I'm going to plug these ciphertexts into this funny algorithm called addition, and it's going to magically get me a new ciphertext that, when I decrypt it, gives me the right answer for adding 5 and 7. So this is very much the idea, again, that I can do some kind of useful computational work for you, potentially, on a sense like your real data, but then I don't have to see the data. So, and in this line of conversation, like if I'm living on the right-hand side of the black line, you can give me stuff and I can write programs to manipulate it for you and figure things out potentially. I'm not seeing any of the data. I'm just moving it around and giving it back to you all as ciphertext. Okay.
I guess my only question would be that that's great, but how do you know that your code worked?
Yeah, well, so I there's a couple ways I could interpret that. Yeah, so it's rough if you're doing something where you would like to reality check numbers, depending on where you are in the, if you get to see the end answers or not. So yeah, maybe a valid criticism here is if I'm building stuff on the right-hand side of the black line, as things are set up, I don't have a way of checking that I didn't screw up a negative sign or something like that, because I can't actually see the answers. Is that what you were thinking about?
Yes.
Yeah, so you got to be careful. In practice, you wouldn't, I guess you probably wouldn't go straight to implementing something super complicated, kind of ad hoc in a blind way. But yeah, I mean, it's definitely difficult. Also, speaking from personal experience as somebody who's built this kind of stuff, it's hard to debug. So also, I should say, we are a company working on making software tools to kind of take this part out of your hands to some degree. And that, you don't have to do anything new and weird to know that you're implementing the right thing. I'll come back to that. Anyway, another term, any of you guys happen to be interested in the cryptocurrency world? Show of hands.
Well, the I don't know that I have any interest in it personally. I work in the financial world. I work for a company that clears options.
Oh, nice, interesting.
We're the only company actually that clears options.
Well, I could probably figure out what company it is then.
Well, it's the OCC is the name of the company.
Yeah.
Options Clearing Corporation.
Well, that's probably matter of fact. That's good.
But,
okay, so zero knowledge proof. I ask about cryptocurrency because this particular technique has caught on there to a significant degree, and that's where some of the most advanced and well-traveled implementations of these things are right now. So if that kind of stuff interests you, both Zcash and Monero have some pretty advanced techniques of this form. Also, Litecoin added Mimblewimble recently. I'm sorry for these awful names. If you're not interested in that kind of thing. But it's all about providing a higher level of privacy in what goes on the blockchain. I have actually a whole other talk I've given elsewhere about that topic. But anyway, before I go into what a zero knowledge proof is, this one is especially kind of out in the wild lately, and you can go check them out in the way they're applying these things. Okay, so zero knowledge proof. What is it? The idea is that somebody's trying to prove to somebody else that they have some particular piece of information. They don't want to show the piece of information. So a really common example that probably your browser did 400 times today is a digital signature is exactly the zero knowledge proof of you're showing somebody you have the private key that goes with a particular public key, but you're not supposed to actually give them the private key. And this actually works under the hood like the example I'm about to show you. You kind of do some mathematical trick you wouldn't be able to do without the private key. Okay, so this is a classic stolen from Wikipedia example. There's this magic cave that's shaped like a donut. Peggy wants to prove to Victor she has a key to open a little door in the back of the donut-shaped cave. She doesn't want to show Victor how she does it. So in practice, what Peggy could do is she could go into the cave, and Victor could be in the mouth of the cave, and he could yell the path by which he should come back. And so if Peggy is honest that she has this key, she can perform this sort of magic trick of consistently coming back by the path Victor requests. So she must have some kind of solution about the door, which she has now demonstrated without letting Victor see what it is. And so a very similar thing goes on in your digital signature. There's a challenge and response. The challenge is, if you had the private key, you could do this weird mathematical trick to my satisfaction that would go with this public key. If you can do that consistently, then I believe you are who you say you are. If you can't do the magic trick of coming back by the same way in the cave, then I know that you're fibbing, or at least you're unwilling to produce the evidence that you have what you say you have. Okay, so I'll stop there for a second. Does that make sense?
Yeah.
At least a little bit.
Mm-hmm.
Okay,
Yes.
so go ahead. Sorry.
Nope, I was just saying, yep, it makes sense.
Okay, so these two tricks together, they add up to my silly fake audit. And that if you could add the encrypted numbers to get a new encrypted value, that triggers homomorphic encryption. And then somehow proving that ciphertext is equal to 30,173 without needing to see it, that's a zero knowledge proof. But the point is that these different techniques allow you to do a lot, to keep data encrypted and learn just some particular thing you're supposed to learn about it. Whether it's an internal relationship or you're verifying that it's greater than something, less than something, equal to something, whatever. You can do a lot of day-to-day work that people do in information technology systems, and the machine doing the work, or possibly the person building the machine to do the work, don't really need to see the data as they have in the past. Okay, so one more term for this stuff. Has anybody heard of federated learning?
I have not.
Federated learning is kind of like the AI version of this technology. It overlaps quite a bit. There's another area called differential privacy that is also similar. So I maybe, for the purposes of this slide, just want to point out that there's this big universe of things that get called privacy-enhancing technologies. I have picked out a few of the kind of specific terms. In reality, they overlap quite a bit, and it can get a little confusing, and people don't agree where they should overlap. So I would not get too attached to the big names, because I think they'll probably mutate in the future anyway. Okay, so we have a tool that does this kind of stuff. If you've been skeptical of the talk, the kind of concepts, or you found them kind of slippery and difficult to understand, you could go into that binder I linked and just play with the tool, which you might find helpful. And so in this example, this is pretty standard Python syntax. The idea is you're just comparing strings, and they're encrypted strings you're not allowed to see. But then, and you get a true or false like you would if you're doing anything else in Python. But then you don't actually need to see the data. All this conversation could be had without knowing any of what was under it. Just to kind of elaborate, so our particular system, the idea is that you have encrypted data and you want to compute some particular thing on it. So there's a special magic trick to decrypt only the answer to some particular question, not the underlying data. So an example I really like, and I put on our GitHub page. Have you ever been to a bar website and it asks you for your birthday?
Yes.
Mm-hmm.
Yeah, I find this a really funny, like, bad privacy example because your birthday is actually pretty sensitive data. And to give it to a bar website, which is probably not the most thoroughly hosted website, well, some are probably fine, but it's pretty juicy PII to give away just to establish that you're 21 so you can view a website. But what this kind of technique allows is you could collect a birthday that got encrypted on its way out of the browser. And then there's a special computation to say, is somebody with this birthday over the age of 21? Because that's what the actual business need was. Is this person over the age of 21? You don't really need to know their birthday, and maybe you don't even want to know their birthday because that's sensitive PII you could lose and potentially get in trouble for. So the point is, there's a special key that you download from this API service that you can use to get that information. Is this person over 21? And that's it. And this example I've given now is actually a real example you can run on that Binder server.
When I put in my birthday in any website, it usually fails the reasonableness checks.
Okay, yeah, maybe.
I got comes back and says you can't be that old.
Yeah. Well, you could even put in some kind of technique so that it checks whether to make fun of you for being too old without really knowing your birthday, which once again is pretty sensitive PII, right?
Yeah.
Anyway, this is probably a good segue. This is kind of, like a calling for me. I think a lot of data gets circulated around that is pretty compromising, and we don't really have to do things the way we're doing them. And there's a lot of opportunity to leverage technology to do things both better, and I think also there's a lot of cool opportunities to build things out there that don't get taken because people, they kind of fear they don't have good solutions to these data privacy problems. And Facebook's conundrum is an interesting one in that they're kind of trapped. They're kind of trapped because the technology is just now appearing to sort of give them good options. Anyway, so I'm in the twilight of the presentation here. There's a couple of things we could go back to. Just want to point you, and these are links if you have the PDF, which once again you can get on GitHub. There's a lot of other people working on this stuff, and it's moving really fast lately, and it's really exciting. Interesting backstory. There was a really big breakthrough in academia in 2009 that kind of let people know this was possible. So now it's sort of the first generation of people bringing out tools in the hopes that, the wider world does these things. So I just want to spotlight a few things. OpenMind is a sort of open source consortium. They're fairly famous. They maintain and mirror a lot of libraries doing this kind of stuff. They're not like a for-profit company, which, depending on why you're looking for them, might be good or bad. There's a really big kind of kitchen sink of a project called Fate. This Chinese bank did it. They've got about every federated learning algorithm out there from some random paper implemented in this thing, and they'll link you to the paper. It's kind of a big and clunky piece of software as I understand it, but it's certainly like a great resource for they've implemented all these things, and there's lots of research up about exactly what they've implemented and how it works. A couple other, and these people are kind of my competitors, but multi-party computation is a slightly different spin on the same thing. Once again, the idea is about pooling data with somebody else. So a lot of the sort of business settings where people are interested in this, like how can I collaborate with somebody else without having to give them my data wholesale? And multi-party computation is yet another big term for that sort of niche. Anyway, there's quite a few of these projects out there. They suit different things. Once again, my company also puts out a library that we're shooting for being very easy to use and fitting well within the sort of everyday usage experience of the average data engineer. But if you're interested in some of this sort of history, I hope some of what's in this deck is useful to you. I'll stop here. There's a couple of slides I skipped we might want to go back on, maybe be a little more conversational for a second. I'm going to turn off screen share in just a second, but once again, here's my contact info. And then if you go to our GitHub, you can get under that binder again if you lost the link. All the information to get in touch with me if you want.
Really cool. Let me ask you, it seems to me like good actors that want to maybe reduce liability have a really good use case for this. But, and correct me if I'm wrong, because I'm trying to kind of work through all this, but if I can calculate a decrypted answer, presumably, depending on other data that I may gather from, let's say, individual rows, right? If we're talking kind of row store, I may be able to infer the values that I'm using for the computations by, let's say, okay, this row minus this row equals this row minus this row equals this row minus this row equals this. Now, if I go back and kind of switch some of those out, I may be able to figure out the actual values. Now, mind you, that would take a lot of work, but at the same time, if I'm just saying, look, I think most people that work for my company are good, I'm just trying to keep them safe because they don't need to see this data. They may not even want to see this data. Then that may be, then it's certainly a good thing. But correct me if I'm wrong on the other side.
Yeah, so there's what's called the 20 questions problem. I call it the 20 questions problem. The best you can do is that you give people only the plain text that they need for a business reason in real life. And for different roles, some it's pretty cut and dried that there's a lot less than you can give them than the whole data. There's lots of actors where it does get into like you're if you answer enough questions, yeah, you've kind of screwed up a lot of the point in that you can reconstruct the data. And so once again, like we have a complicated permission system. In any setting where you're putting out an endpoint for anybody, you want to be on the lookout for people submitting lots of requests that look abusive. So it takes you straight back into a lot of pretty conventional, cybersecurity and just utilization, sanity, maintenance kind of issues. So a really good example of, that bar example, yeah, you don't ever really need to see the birthday at all. You could give the permissions serving that application, that box has permissions just to see that. At the other end of the spectrum, and this is kind of like a pipe dream for us, like a data scientist or a data analyst, their job, one way you could put the job, and some people would really disagree with this, is you're trying to construct a narrative about the data that's useful to some business decision maker. And probably as part of doing that, you look at the data a lot. It's much harder, although I would not say impossible, to give that data science person a profile of what they're allowed to see that isn't either, okay, I let you see too much and you can do a bunch of abusive requests and figure everything out, versus, well, I didn't really give you enough to do your job. Beyond the boundaries of this presentation, there's a slightly different kind of technology. It's like the privacy enhancing text space, but it's a little bit of a different kind of solution. Touches my world quite a bit. There's like a differential privacy, if you've ever heard this term, is sort of a very sophisticated way of adding just enough noise on top of the data. And it tends to work better in this kind of setting. So for example, if you're querying something about what's the average spend in this zip code, if I added a little noise to everybody, that would not really affect your number enough for you to care. It sounds stupid, and I was a skeptic of the technology for long. I shouldn't call it stupid because I'm trying to say it's good right now. But in a way, it works better than encryption in the right setting from a privacy standpoint, because everybody blurs in with everybody else. And there's a high level of privacy. And you can say somebody spent a lot of money in this marketing data, but because I've fudged these numbers all a little bit, it's no longer really workable to play that game you were talking about of doing all the comparisons and working backwards.
Okay. Yeah, it's cool because so my background on encryption is strictly limited to what's in SQL Server, and we have always encrypted now, where like the database holds the encrypted data. Okay. But the keys are not hosted by the database. They've got metadata to basically say, hey, you should go look here for the key. And if you've got access to it, you can decrypt the data, right? So it's all kind of client side, which is really interesting to me because there's the two different sides of this, deterministic and random. And so the random stuff, right? When you encrypt one, and then I encrypt one using the same key, it encrypts to something different, right, for each of us.
Yeah.
Versus deterministic, yes, which sounds like this, which is deterministic, right, which means 72 always encrypts to 72, meaning that I can do operations with it, but unless I have access to that private key, I can never actually see what the data is. The engine can do operations with it, or your library, right, can do the operations with it. But unless I have access to that private key and somehow invoke it to decrypt the data, I'll never know what those values are.
Yeah, you absolutely have the right idea. I need to correct you on one thing. Of all these homomorphic encryption techniques, it absolutely has to be true that if you encrypt one twice, you get different values one way or another. If for no reason other than there's lots of attacks that become possible. And just like a thought experiment, if you have encrypted 1 and you want to add encrypted 0 to it, you should get encrypted 1 again. But then if you don't make it a different ciphertext than you started with, you've just given away what 0 is, for example. So ciphertext has to be like highly non-unique in any of these approaches. There's a third sector of this privacy enhancing text space. I admittedly don't know that well, and I want to be careful about saying the wrong thing, but name is like, I guess Secure Enclave is a little bit older, and now there's trusted execution environments. But it's a very similar story with decryption doesn't occur outside of a specialized chip or outside of maybe a special type of virtual environment. So you're trying to accomplish the same thing of you're insulating either the user or the machine from data you think is kind of toxic and sensitive, but then hopefully doing it in a way that you can still carry on a lot of business, hopefully.
Right, and even keeping it from being decrypted in the memory buffers, which is typically what happens, right? But absolutely. I think with the Secure Enclave, which is the only way I know how to determine how to call it, and I'm not an encryption expert by any means. They do, everything's done there, right? And it's specific to the chip that's there, right? TPM.
Yeah, it's interesting stuff. I'm really a software algorithms guy, so I will be quite open that I view it as this kind of triangle, and there's like the encryption-oriented approaches. That's mostly what I talked about. There's the sort of differential privacy synthetic data approaches, which I, being kind of algorithmic, know pretty well. And then the secure enclave corner, I openly, it's not really my background. I think there's a lot of really cool research in that area. So I think we might all be more comfortable with secure enclaves, meaning like there's a special chip, and that's the story. And I think somebody might push back here. They've gone beyond that, both employing different kinds of virtualization. And I think there's also been lots of interesting progress on, well, exactly what is the trick that is performed in the chip. You sound like you might have a little sense of already. It becomes pretty interesting with a lot of these. Who are you trying to protect the data from? Especially, I should say, a lot of the uptake on this kind of tech is stuff like the advertising marketing technology world, where data is passing from company to company a lot. People are pooling data. If you're going to do this in a more kind of purely like internal cybersecurity context, you naturally want to ask the question like, well, who is the person you're worried about losing the data, right? And that informs
Totally.
like,
Yeah.
is it worth, is it just doing the computations inside the chip? Does that actually make a difference, or do we have to go put them somewhere else where it's still a problem, etc.?
And as you said, right, any good cybersecurity plan is going to be layers, right? So we got to protect from the outside in, and this is just another layer.
Yeah, absolutely. One interesting thing about this kind of technology, lots of the benefit if you do the whole data pipeline, but if you're living my life and you're trying to persuade people to do this, it becomes about what is the sort of hole in what you have now, right? Like even if it's supposed to be pervasive encryption technology, people are motivated by the hole in what they have now, of course. Cool. What's up with you? I'd like to learn more about you guys' YouTube channel. I post a lot of content. Maybe this is important for the recorded part, but maybe you can edit it. You're welcome to put it on there. I do a lot of similar like recording broadly. So if I could give you like a shout out on LinkedIn and point to the recording or something like that, if that would be helpful, I'd be happy to do it.
Yeah, for sure. For sure.
Yeah, absolutely.
Okay, other questions? Want to see anything else?
I'm good. It was cool. And what I like about it for me, having such a shallow understanding of encryption, is I definitely got not only to kind of see your solution product offering, but it also gave me a much better understanding. So thank you.
Yeah, I think it's super important. It's pretty new, and I try to tell people about who cares and why might this be important. So if I succeeded in a little of that, that's great. I'm just showing the binder now. In a second, it's going to spit out a Jupyter notebook. I think this is the easiest, just tinker around with this stuff that's out there. So if you're interested or you run into anybody that's interested and you can tolerate Python, then you just got to click it and then it'll pop up.
Okay, cool.
All right, you guys have a great evening. It was good that we finally got it scheduled. I think I initially reached out to you back in March, maybe. So
Yeah, and I apologize about that. I know I screwed up one time. You can blame my memory for that.
well, the Meetup Messenger has been terrible, and one disadvantage I had was just generally interacting with the thing is that you typically make contact with people over the messenger, but then the messenger is kind of unreliable. Okay, you guys, best of luck. The slides are there if you ever want to read them again, and I hope you learned something.
Thank you very
Awesome.
much, Alexander.
Yeah, thank you so much, Alex.
Bye-bye.
Bye.
Bye now.